Good morning, everyone. We'll start the session in more 2 minutes. Please message me if you guys are unable to hear me. Please let me know. A warm welcome to everyone for this webinar session to validate designs quickly and easily with SolidWorks integrated simulation. Before I start up, I wanted to introduce myself to everyone in the session here. I am Chetan Kumar, working as an application engineer for simulation. I work for Beacon Pune. Okay. Please feel free to put questions. You have a question pen down there. You have any doubts, you can just put down the questions at by the end of the session. Right. We'll move forward with the session right now. Let me start up with a small next slide. Yeah. Just please let me know if you have any problem in viewing the in the slides, or if you are unable to hear any if you are unable to hear my voice. Okay, for today's focus, it would be with the SolidWorks simulation. I will try to focus basically with on these 4 points. How does a SolidWorks simulation can help you out in improving your everyday productivity, and how exactly SolidWorks simulation can help you out in optimizing your work process, and how does SolidWorks simulation can reduce your operational costs, and how exactly SolidWorks simulation even can also help you out in solving more design challenges. So this would be my main focus on these 4 points for this presentation, and I'll also try to show you out how exactly SolidWorks simulation environment looks like, and how exactly SolidWorks simulation can help you out in making your product validated. So let me start up with the basic thing. This is basically the simulation dashboard, SolidWorks simulation dashboard. We have different products in SolidWorks simulation. We have a SolidWorks simulation which deals with finite element analysis, uh, uh, where you can do static and other fatigue or thermal, some non-linear, all kind of analysis can be done in SolidWorks simulation. We have something called SolidWorks Motion. If you're working with something with motion analysis, we have something called SolidWorks Motion. We have SolidWorks Flow Simulation as well. You must be definitely aware of the term called CFD. So flow simulation is working on basically a CFD code. We have something called SolidWorks Sustainability, and we have something called SolidWorks Plastics. But today's focus will be mostly on SolidWorks simulation. So, like I'm definitely sure that you are already users of SolidWorks. So, similarly, what we have in the SolidWorks, the standards like SolidWorks Standard, SolidWorks Professional, and SolidWorks Premium. Each module has its own features, keeping on adding in. In the similar way, we have three modules of simulation, which is SolidWorks Simulation Standard, which includes a linear static analysis and fatigue analysis, where you can predict your lifetime. And we have other than these two, we have SolidWorks Motion. Again, in motion we have two kinds of motion analysis. One is time based, another one is event based. But whereas in simulation standard, I haven't put the picture of it, but we can do some time based motion analysis. Other than that, we have something called simulation professional, which is dealing with some frequency analysis to calculate some natural frequencies of your assemblies or parts. We can do buckling, we can calculate buckling load factors, we can do thermal, where you can calculate the temperature distributions, and also we can calculate the thermal stresses. We can do optimization of your product depending upon what your constraints are. We can do some pressure vessel analysis, which is a combination of different studies like thermal or static or some other kind of loads included in it. We can do drop test, which is a part of dynamic analysis. These are the modules which includes simulation professional. Plus, like what I've mentioned previously, we can do time based in simulation standard, and event based is included in simulation professional. Other than this, we have something called simulation premium, which deals with non-linearities. If you're working with some non-linear materials like rubbers or some plastics, or not non-linearity doesn't have to be only the material, but it might be a loads as well, like the load varying with respect to time, or non-linearity contacts. All kind of analysis can be done in non-linear analysis. We can do some time history, harmonic and random vibration and response spectra if you're working with some dynamic analysis. And we have a separate module for the composites, and everything is included in premium. But for today's focus would be only on simulation standard. That means I'll focus only on linear static, fatigue, and time-based motion analysis. So to start up with, what exactly static simulation or linear static simulation is, we basically calculate what are the stresses in your part or in an assembly is. We can also calculate the displacements. We can also check out what the factor of safety of your product is. I'll try to show you a simple animation of the video. Maybe you can, that might be easier for you to understand. At the bottom right corner, you can see a small animation playing down there. We can calculate, different kinds of designs. You can check out with the different designs. We can calculate the factor of safety, like I mentioned. Now let me go into a small project description of static simulation. I'm basically going to work out on two different configurations of a bracket, which are named as a symmetric bracket and a channel bracket. I have two different configurations. I assume that everyone are aware of configurations, but if you are not aware of configurations, I'm going to show you what configurations are as well. But yes, I'm going to focus mostly on these two products, that is a symmetric bracket and a channel bracket. And I'm also going to work out on two different boundary conditions, which are I'm going to work out on two different boundary conditions as well. The boundary conditions would be my fixed boundary condition and a bolted boundary condition. At the end of the demo, it is something like I have four different studies, that is each configuration with two different boundary conditions. So I would like to switch quickly to SolidWorks simulation and see how my work environment of SolidWorks simulation looks like. Yeah, hope you guys are able to see my window. So I've just made two configurations, which is in my configurations manager. You can see that I have two different designs, which is my symmetric and which is my channel configuration, and my symmetric configuration. So these two are the configurations which I'm going to work on right now. So since you have made your design tree right now here, okay, I'm going to create a new study. Okay, before we start up, this is a simulation tab, which is an add-in to your SolidWorks CAD module. So that has to be added in your add-ins, which has to be enabled on as a simulation, SolidWorks simulation on both the sides, and just click OK. Once you click OK, you get your simulation tab activated on the top. Okay, and then I just come down to the study advisor and just create a new study there. So you can see that I have different kinds of studies coming up. So depending on what license you have been taken up to work out, those modules are automatically activated. So I'm going to work on my static, and you can just give the name of the static. Let me say I'm going to work on symmetric, so I'll just name it as symmetric with some fixed boundary condition, and just click OK on the top. Okay, once I click OK, a new study appears up at the bottom for me. You can see down there, right? So you can see that this is my part, and the basic thing is, so the first thing what I'm going to do is I'm going to apply a material to this. So that can be done by just right click on the part and click edit material, and I have standard materials down there. So I'm just using a gray cast iron as my standard material, and I just click apply to that. So once I click apply, my material is applied to the part. But then if you're already assigning a material to your part in your model tree, so you don't have to assign the material anymore in your simulation tree. It automatically takes in from the CAD, right? So now, like what I've mentioned, I'm going to do two different boundary conditions. So I have different kinds of fixtures. I'm just going to take a fixed geometry, and I'm going to select this face down there and click OK. And I'm going to apply some load. I'm going to apply force. You can see different kinds of loads. I'm going to apply force on this particular face, but my load is actually not going to be in that particular direction. I want it on a specific direction. So I'm just going to select the direction and select the reference face or a plane, and then just come down and make it normal to that, but in a reverse direction with a value of 200 newtons, and just click OK. Okay, once I click OK, I'll just try to show you out what my fixture is and what my load is. You can see that my load is automatically appearing up down there, and I have an option of just run the analysis, so that software is smart enough to move forward with automatic meshing. But then if you are really interested in giving up some local controls, or you wanted to play with the mesh size, or you wanted to play with some different kinds of meshes, all those options are available in your mesh. Okay, I'll just try to show up what are the options available down there. So I just come down there. I have different kinds of curvature based, standard based. I can play with the mesh size. You can play with the refinement of the mesh, or if you wanted to go for some mesh control, just right click and go for apply mesh control and select the face or the edge or the vertex, and you can play with the mesh control at localized mesh, local mesh. That is also possible. But then to make it easier, I'm just going with some default mesh down there, and I'm just going to run the analysis. Once I run the analysis, I get different outputs down there, and that is nothing but my stresses. So you can see how my stresses are generated with the load and the boundary condition what I've applied. So my maximum stress is 8.4 megapascals, which can be seen to the pane on the right side. But then if you wanted to look out where exactly my maximum stresses are generated, just right click on your stresses and go for edit definition, and we have something called chat options, and you can just select your maximum location and just click OK. So once I click OK on the top, you can see that this is the location where my maximum stress is generated. Okay, you can just play down there, and now you can see where my maximum stress is generated. Right? But then if you wanted to, people are more curious about these colorful plots. Let me say, if I zoom in, you have some nice transition, from red to yellow, or yellow to green, or green to blue. If you are interested in finding out the values, and you might have a question, how do I need to calculate, or how do I need to know the value of the stress generated at this particular transition state? That can be done by just selecting an option called probe in your stresses. Select the probe and place your cursor anywhere on the window. It shows up the value of your stress at the particular location where you have selected. So I'm just selecting down the value, selecting a location in the green, so it shows up value there. If I'm going to put up in the transition down there, it shows me a value up there. So all these options are available to play out and calculate what your outputs are. But then other than that, you can calculate the displacements. So my maximum displacement is around 0.169 mm. But then you might have a question in your mind, 0.16 is too small, but then whereas the displacement showed here is quite big enough. So but then you can see on the top with my deformation scale as 245.34. So that is, it is something like zooming out or looking out at a microscopic level to see how your product is deforming. But then if you wanted to change the deformation scale, it is as easy as that. Just go to your edit definition, and I have something called automatic, which is automatically generated by the software. But then you can just put it into true scale and just click OK. You can see down now how my displacement is actually with a deformation scale of 1. But then I just wanted to go with some automatic. I'll let you know why, and just click OK. And now I'm just trying to just click animate, so that it shows me up how my model is going to deform. And you can wanted to control the frames. You can also even control the frames as well. You can see the number of frames, so that it is easy to for me to look out how my model is behaving actually. And you can also calculate factor of safety. So my factor of safety, minimum factor of safety is around 13.9. So my factor of safety is 14 for the whole design. That is also possible to check it out. Now the question arises. Now I'm going to this is my one study, with one boundary condition. But then, like what I mentioned in my previous slide, I wanted to change the boundary condition, right? So what I'm going to do, basically, what you are going to do is, again, you are going to create a new study down there, and select the study name and just click OK, and all the stuff you have to repeat the things. Instead, SolidWorks provides you to minimize your work, or that is what I wanted to say, like what I mentioned in my second slide, optimize your work process. So how to do that? We have an option to duplicate your study, right? So I'm going to duplicate my study, and you can give the name as symmetric channel, let me say, sorry, symmetric bolted. So I'll just give it as a symmetric bolted and just click OK. Once I click OK, a new tab forms up down there with a symmetric bolted. A new study forms up down there with a symmetric bolted. But whereas if you see out, my fixtures are similar as what I've duplicated. But then if you look out, or if you think it logically, nothing is changing in my study other than my boundary condition. So if you see there, my material has been transferred, and my loads are transferred. But whereas if I come down to the fixtures, what I'm going to do, I'm just going to delete the fixture where I've duplicated it, and I'm just going to create a new fixture which is nothing but a foundation bolt. So I'll just select the the location where I have to select the bolt and click OK. So I've just created 4 different bolts. So I've just created 4 different bolts. So you can see now my boundary condition has been changed, right? So I'm just going to duplicate the study, and I'm just going to change the boundary condition, nothing else. So my mesh, my loads, my materials, everything is transferred into the new study. So I just have to rerun the analysis. Once I run the analysis, again I get my outputs. So that is nothing but these are my stresses now with a different boundary condition, whereas my loads, my material are same. So but you can see that my maximum stress generated are around 8.8 megapascals with just my changing the boundary condition. Okay, and I can also calculate my displacements. So my displacement is around 0.2, whereas in my previous study is around 0.16 or 17 mm. But then I have something called factor of safety. I can also check out what my factor of safety is. It is around 9.3 with this boundary condition, whereas in my previous study it was around 14. And even I have an option called check out the forces generated on the bolts. So if I go for check bolt of the thing and just click details, so it also shows me up a window where all my forces on 4 different kinds of bolts are. So you can see that on my foundation bolt 1, my shear force, my axial force, and bending moment. So bolt 2, bolt 3, and bolt 4. So what are the forces generated on these bolts are also possible to check it out. And if you wanted to save it, you can just save it as an Excel sheet, so that you don't have to always come in and check it out what are the forces generated. And once I just click OK, I am going back to my normal state, and I'll just click stresses. Let me say these are my stresses now. So again, I'm coming back to the same point again. This is how you can optimize your work. You can reduce, you can minimize your work content more than half, just not by creating a new study, but just by duplicating the study, and just by playing with the whatever the options you wanted to change with. Let me say like boundary conditions or the force value or the material, or whatever it is. Now, like what I've mentioned, now I have already two studies with one configuration. No, but then I wanted to create a study on another configuration that is nothing but my channel. So let me go with symmetric fixed, and I wanted to do the same study, which is fixed condition and the loading condition with the channel. So I'm just going to duplicate this study, and I'm going to use the configuration used as a channel. Okay, once I click it as a channel and click OK, so I have got my new study with channel. But the only thing is, I just have to right click anywhere and just activate that configuration, and just let me show my fixtures and the loads. So you can see all my boundary conditions, the loads, the material, and the mesh, everything is transferred to the new configuration. Whereas I don't have to create a new study again and again. So I'm just going to run this analysis, and I can check out what my stresses are. You can check out in this configuration, my stresses are around 11.3 megapascals. And you can, if you want to check out factor of safety, yes, of course, you can check out my factor of safety is around 16 here, down there. So if you wanted to go for a bolted condition, I'm just going to duplicate this study and create a new study with bolted. So I'm just going to make a new bolt study down there with the same loads, and I'm going to run my analysis, and I get my outputs, and these are my stresses. So the stresses in this study is around 20.2 megapascals. So now you might you wanted to compare the results. Now I have now 4 different studies, 2 different configurations with 2 different boundary conditions. And the basic way what you do is make an Excel sheet or take down a paper and a pen and write it down. But instead, Solidworks provides you something called compare results. So I'm going to compare my results. Since I've made different studies with the 2 configurations, I'm going to use all studies in all configurations. So I'm just at the max I can select only 4 options. So let me go with only the stress values. I'm just selecting the stress values of all 4 different studies and just click OK. So I get down with the window with the stresses of all 4 different studies. Okay, so you can check it out. Okay, with symmetric I have 2 values with 2 values, and with the channel I have 2 values. It's not only showing you up down there, but also you can play within the same window. So it is more realistic to see where my maximum or how my stresses are distributed. You can just play around and see. And once I just click exit, I can come out of the comparison. So if you wanted to check out with the displacements, just select with the displacement option rather than other than stresses in the compare options. Now the tedious task for any engineer would be most of the times would be trying to generate a report to send it to the manager or to the customer. So most of the times what we do is we open up Windows format and take the snapshots of these pictures or everything and note it down. Instead, we have an option called report. So you can just write down on the top. You can see an option down there on the top. I can write down the description of the project and the assumptions of the project. If you wanted to add some assumptions, you can just add up some assumptions. And if you don't want any one of these options to appearing up in your report, you can just disable them, like contact information, or if you don't have any sensor details, or if you don't have any resultant force, or if you are not working with anything with the beams, you can just delete them or check out or disable them, so that those options doesn't appear up in your report. And if you can add up some header information, your designer name, your company name, URL, logo. You can just add up your header information and just click publish at the bottom. Okay, once I click publish, so it automatically generates a report. Let me say again, I'm trying to optimize my work process. This is a simple part, so it is trying to solve out within soon. But if you're working with some assembly, let me say with 20 parts or 30 parts, what you can do is you just generate a report, go back for your lunch and come back. Your report is ready, so that you can just look at out the report, how it is generated, quite neat and beautiful, and can just forward it to your manager or to the customer you're working out with. So again, I'm trying to focus on the same thing, optimize your work process. So I get my model information, I get my mass, volume, density, what are my volumetric properties, how it is treated as, what are my study. I'm doing my static study, I'm doing some solid mesh, what are my units of the study, what are my material properties. So this is my gray cast iron, my material properties, my yield strength, my tensile strength, my elastic modulus, everything is coming down there. These are my fixtures. I have 4 different bolts, the size of the bolts, what kind of force I've taken with a 200 Newton force. I come down, what kind of mesh I have, how many number of nodes, how many number of elements. This is how my mesh looks like. I can see out my results now. So these are my stresses. So my maximum stress at this particular node, my minimum stress at this particular node, what kind of stresses it is. I can see my displacements. I can see my strain plot. I can see my factor of safety. And if you have any conclusion to write down, you can just write it down. Your report is ready with you within just a click. Now I would like to quickly switch to the presentation slide. Like what I've mentioned, I just wanted to go with the results what I've done. So like what I've done, the comparison down there, I'm trying to put it in a tabular form here. So I have 2 different boundary conditions with 2 different configurations. So I'm just putting out there, these are my stresses. So these are my displacements. This is my factor of safety. And other than that, I have something called fatigue. Fatigue simulation is something where you wanted to predict your lifetime of your product when you're undergoing some cyclic loadings. But the only input what would require is the SN curve for different material types, and you can calculate the load, the total life and the damage of your product. Let me quickly switch to the before I switch off, I just wanted to go you through the next slide. So I'm going to work on 3 different configurations of my bicycle crank. I have 3 different designs. So, but then I wanted to choose one design. But then my criteria for the design is that it has to withstand for at least 7 million cycles. It has to withstand for at least 7 million cycles with the maximum load, which is able to take around 13-15 newtons of the force acting on the pedal. So to do my fatigue analysis, I need some reference study because fatigue is calculated with the stresses generated. So I'm going to do some reference study, that is nothing but in this case I'm going to do some static study. Like what I've mentioned, I need the material properties, the connections and the loads applied, and the outputs what I can calculate are the stresses, displacements and the factor of safety for all 3 configurations. And once I do my static analysis, I am going to do my fatigue analysis and predict the lifetime of each product or each design with the stresses generated in my static study. So for my fatigue analysis, I need only 2 inputs, that is nothing but my loading event, that is nothing but my criteria, which is 7 million cycles, and the SN curve of the material. So let me quickly switch to the Solidworks and let me show you out what my designs are. So I have made three different configurations. So you can see this is my design 1, this is my design 2, and this is my design 3. Alright, so I'm going to start up with my design 1. So like what I mentioned in my previous product, I'm going to start a new study with a static study, because for the fatigue I need static analysis to be done, and I create a static study which is named by static 1 at the bottom. So you can see down there I have now three different parts. So I can assign the material for each part separately if you are working out with the different materials at different parts. And I have to mention the connections, how the parts are connected to each other, and I have to show out my fixtures down there. So I have some fixed hinge boundary condition on these 6 faces because it has to be freely rotated, and I have another fixed hinge condition on this face because it has to be freely rotated at that location as well. And I'm going to apply a load of 1350 newtons on the pedal. So you can see the load applied on this 1350 newtons on this phase, and I'm going to run the analysis, and I get my outputs for the design 1. So these are my stress generated in the design 1. So my maximum stress generated is 215 megapascals at, let me say, this particular location. Now it is up to you. If you wanted to go for fatigue for the design 1, you can directly go for fatigue, but I go for static. I wanted to finish off all the static studies, so I'm just going to duplicate this study and go with design 2 and just click OK and rename it as static 2 and just click OK. Once I click OK, I have my static design 2. I'm just going to activate that configuration, and I'm just going to run the analysis. Once I run the analysis, again I get my outputs, the stresses, the displacement, and the factor of safety in the design 2. In the similar way, I'm going to do for my static design 3 as well. I'm just going to duplicate the study and select the design 3 configuration, and I'm going to run my stress value, static analysis for the design 3. Right, once I've done my static analysis, I have to do my fatigue analysis. So to do that, I have to come down and select a new study down there and go for an option called fatigue here and just click OK on the top. Once I click OK, I get my fatigue study. So now you can see that I have different materials. So I have my fatigue data, which is nothing but the SN curve. So it has to be taken by your material vendor, but it is a mandatory. Once I apply the material data, I have an event, which is nothing but my loading event, which is 7 million cycles. And this is a study for my design 1. So I have to take a reference of my static 1 so that the stresses are automatically transferred into the fatigue study, and just click OK on the top, and I just run my analysis. So once I run my analysis, I get my damage percentage plot where I can see the maximum damage, and I can see my maximum damage is around 173, but then after how many number of cycles it is going to damage can be seen in your life cycles. So my life cycle is around 4 million for design study 1. So in the similar way, I'm just going to duplicate the study, and I'm going to use design 2 and just click OK. So I get my fatigue design 2. I just have to go and activate that configuration. And here I'm going to add my event again. It is nothing but my 7 million cycles, but here it has to be taken as a static design 2 because it is my design 2. So the reference study taken is a static study done for your design 2. And once I just click OK, I run my analysis. Once I run my analysis, I get my outputs. So I get my damage percentage. Let me see where the damage percentage is actually happening. Okay, it is somewhere down there. Okay, so my maximum damage percentage is around 47 percentage, but then I wanted to see at after how many cycles it is going to damage. So just click my life cycles. So I get around 14 million cycles is my minimum lifetime. So I'm going to duplicate this study. I get my fatigue design 3 as well. So I'm going to do my same study again, but I have to just activate that configuration. Just calculate the damage percentage, which is around 648 percentage it says, but then let me see after the lifetime. So I have around 1 million. Okay, so I have 3 different designs. I have my lifetime predicted with the same loadings. So I can just calculate. I'm just going to put a small tabular form that my design 1 can withstand for 4 million cycles with a factor of safety of 1.28, whereas my design 2 can stay for 14 million with a factor of safety of 1.4, whereas my design 3 stays for 1 million with a factor of safety of 1.1. So I'm going to choose a design 2 so that because it is fulfilling my criteria of 7 million cycles. And you can if you wanted to make some changes, or if you wanted to improve in a design, improve your design, you don't have to focus on design 1 and design 3 anymore. So you can just focus on design 2 so that you can get much better outputs. So again, I'm trying to point the same thing: optimize your work process, solve more design challenges, which is the last point. So I have different designs. I have challenges to come out which design is the better. So I this is the way how I can solve more design challenges and move forward. But other than that, like what I mentioned, we are only going to focus on simulation standard. I have something called time-based motion analysis. So in the time-based motion analysis, basically we can calculate the specific needs of the motors, or the cylinders and the motors required. Test the mechanism whether your assembly is working fine or not. We have options of giving different frictions. We can give dynamic frictions, static frictions. We can take damping into consideration. But then I just wanted to switch quickly to SolidWorks, and I wanted to wrap it up soon because so I have something called time-based motion analysis. So let me say I'm definitely sure one or the other would have definitely visited your dental doctor, or if not, you are going to visit soon in your lifetime once. But then this dental chair is having some kind of mechanism because you wanted the doctor wanted to be more flexible to work with your teeth. So it has to be flexible to move. But then you wanted to see how the mechanism of the chain is actually happening. It depends on the weight of the person to lift it. So again, emotion is another add-in. I'm going to go down there and check out whether my SolidWorks motion is activated or not. Once I check out my SolidWorks motion, if you come down to your motion study at the bottom, I have a motion study down there. So I just click up. We have something called animation down there, right? But if you come down, you have something called motion analysis. This option comes up only when you have SolidWorks motion activated in your add-ins. So I've created a new study, which is where I have taken some linear motor at this location. So my SolidWorks motion basically works with the mates. So you have to be definitely aware of using the mates. It totally works on how the mates are given in your assembly. But then you can give some local mates in your motion study as well. If you are not working out with the mates in the assembly, if you can play with the mates within your motion tab as well. So I'm just applying some linear motor. I have different kinds of motors appearing up here. So if I right click on, so how to give up the motor, that is a big question. I have different options down there. I have motors, I have springs, I have dampers, I can give force, I can select the contacts, I can select the effect of gravity. So I'm just going to select a motor. Once I select the motor, I have different kinds of motors, rotary or linear. I'm just going to select the linear motor. And at what component you wanted to use it, just select the component and just come down there. What kind of motion is it? Is it working with some constant speed, or you want to play with some distance? I mean, distance is nothing but you wanted to move it a distance of 100 meters within a time period of whatever the time period you want. So you have different options to play down. Okay, so I've just generated a linear motor down there. So I've taken an option of different segments. You can see that it has to move, it has to have a path of something like that. Even you can give in terms of expressions, or all these options are possible. So I've just generated a linear motor down there, and I have to set the time phrase of the motor, of the event to be happen, because it is time based motion. So I'm just now selecting a time second of 4.1 seconds, and I'm taking an effect of gravity in the y direction. You can see down there in my negative y direction, which is appearing up at the window in the green color. And I just click OK, and I just click calculate. Once I calculate, it calculates the motor capacity required and the displacements and everything. And I can just minimize this and zoom to the window so that you can see how my actual motion is happening. Once I just play, you can see that how my actual mechanism of this assembly is actually working out within a time period of 4.1 seconds. So at the end, I can calculate my outputs. That is nothing but my results and plots. I go to my results and plots. Let me say I wanted to calculate the displacement. So I select the displacement, and I just wanted to calculate the linear displacement and the magnitude, and let me say any particular point, or any particular phase, or any particular edge. I'll just select that. Let me select this vertex and just click OK. So you can see it in my results plot. So I've calculated the displacement on this face. That is nothing but my this thing, and just click OK, and I can show the plot. So it shows that in a time period of 4.1 seconds, it reaches a maximum height of around 0.7 meters, right? And this reaches at a time period of around 2.5 seconds, 0.5 seconds, and come down to the normal state within a time period of 4.1 seconds. So this is how you can calculate the linear displacement of your the assembly. Or if you wanted to calculate your motor force, I've generated some motor force as well. I think something is wrong down there. I'm unable to show the motor force, but the force required for this operation to be calculated, that can be done by calculating, come down, select the forces and motor force, and just select the magnitude, and select the linear motor, and just click OK. It shows up a graph what is the force required for this particular operation to be successful. Now I would like to end up by just adding up a summary. That is nothing but like what I've mentioned, it is integrated with CAD. The thing is, if you wanted to make some changes after doing some static analysis or fatigue, or doing some time based, or whatever the analysis you wanted to do, if you wanted to make some changes like what I mentioned, it is integrated with CAD. So just switch down to your model window, like let me show you the study. So this is my static simulation study, and if you wanted to make some changes, just switch back to your this is my simulation study. Want to make some changes, switch back to your model, make the changes, necessary changes, just update your model on the top, and come back to your simulation and just run the analysis. So this is integrated with CAD, and it is very powerful and easy to use. Since it is integrated with CAD, you don't have any loss of data in the CAD, and it is in the similar platform of the Windows, like what you have seen. You can generate the reports, you can compare the results, you can see where my maximum stresses are generated, not only at the maximum stresses, but any location you wanted to see the stresses are generated. It is very easy to use, and it is coupled simulation. What I mean to say, coupled, if you're working with some flow or if you're working with some thermal, and how to integrate the flow into static or thermal into static and calculate what the outputs are, those are also possible to calculate. Uh, that's all from my end. Please free feel to put the questions. If you have any questions, please, I appreciate that. I'm going to wait for more a couple of minutes for any questions to be raised, or else I assume that I can end up the session. So static analysis actually means we are considering some assumptions that the loads are not applied all of a sudden. The loads are applied now slowly and gradually. That is the first assumption what you are working with. And the second assumption is that the material is elastic, is performed within its elastic region. Now that means, let me say, if you're doubling your load, then the outputs are two times the load what you have applied. But then the other assumption what you're trying to say is, if you remove the load, there is no permanent deformation. It is going to come back to its original state. So the static simulation is basically working on these three assumptions. The dynamic is something where the load is varying with respect to time. That is coming up into dynamic analysis. Or you have something like sudden loads coming up, shock loads like earthquakes or force generated on your car vehicle if you're going on some bumpy roads. Those are some kind of dynamic analysis, because the loads are not constant. They keep on changing with respect to time. Okay, for to work on some dynamic analysis, we have simulation premium, where we work with dynamic analysis, but whereas simulation standard can be done only with static analysis. I think that should clear your doubt. So again, in fatigue, we have different kinds of fatigue analysis. We can include dynamic analysis as well for the fatigue. What I've done, what I've shown you is for the static, but then if you're working with some dynamic analysis, we have different module for fatigue in the dynamic. Uh, I can show you up there something like this. Just give me a second. I hope you can see the window. Um, so if I'm coming up down to my fatigue, if I just come down there in the fatigue, you can see that I have an option of uh, constant amplitude, variable amplitude, or varying with respect to fatigue, or random vibration fatigue, or dynamic fatigue. So it depends on what kind of loading you are taking. Since I have taken it as a constant amplitude, which is for static, so in this particular example, I am working on uh, the constant amplitude. So if you're working with some dynamic, you can include the dynamic as well for your fatigue analysis. So hydraulic cylinders is the cylinder which is operated hydraulically, which works with hydraulics. It is not working with some motor or something like that, which is working with some hydraulic operations. Uh, that's all I can tell you what exactly hydraulic cylinders are mean. So I assume all the questions are answered, or are you waiting for some more questions to be answered? If it's not, I assume that now I can stop up my session down there. I would like to thank all again for attending the seminar. I wish you have a good time. Thank you.